Hello everyone. We are going to discuss about Dart, which is the language used for Flutter mobile application development. Dart. It is a single-threaded, high-level, object-oriented programming language. So if you have any experience with JavaScript, you already know what is a single-threaded language. So Dart, JavaScript, these are the single-threaded high-level languages. If you talk about Swift, Objective-C, Kotlin, they are multi-threaded. Object-oriented programming language, basically we can create classes, we can initialize the classes, we can and after initializing the classes you will basically get the objects and we can work on those objects. So later we will see in the next slide, we will talk in detail about the object-oriented programming, what exactly it is. That is developed by Google. That is primarily used for building mobile apps and websites. It comes with great libraries, an editor, a virtual machine, and a compiler. Dart improves the performance and productivity of mobile apps. Why Dart improves the performance and productivity? Obviously, you write a single code base, and there are a lot of features in Dart which enforces developers to correct the things at compile time. So whatever issues can happen at runtime in other languages, Dart will try to uh, provide those issues at compile time itself so that you don't have runtime surprises. On October 10, 2011, Dart was, Dart was founded by Lars Bak and Kasper L. Bak, a Danish programmer, developed the V8 JavaScript interpreter for Chrome. V8 is responsible for the Chrome's success. Google moved most of the V8 engineers to Dart project. That is very motivating factor because uh, most of the engineers from V8 they have been deployed into the Dart project. ECMA, European Computer Manufacturers Association, formed a technical committee TC52 to work on Dart language standards. So those TC52 goals are: first, develop Dart standards for libraries that extend the capabilities of Dart. Investigate the future direction of Dart standards and to evaluate and consider proposals for additional technology. Develop test suites that test cases in Dart and to make sure the correct implementation. Establish, maintain, liaison with other TCs and other standards development organizations as appropriate to facilitate the work of the group. Most Dart types are just class or interface types. Everything in Dart is an object. There are no primitive data types. So if you talk about integer, if you talk about float, boolean, which in other languages they are primitive like integer and float, but in the context of Dart, everything is an object. So a integer is an object, a float is an object, a boolean is an object. Specifying static types clarifies your intent and enables static checking by tools, but it's optional. So either you can declare your variable with statically declaring the type, or you can just write var I equal to 10. So you don't need to write integer or something. Just write var I equal to 10. Bool are just normal objects. They are no more primitive data types. Dart is type safe. It uses a combination of static type checking and runtime checks to ensure that A variable's value always matches the variable's static type. We will see with the code examples, it will make more sense gradually. Although types are mandatory, type annotations are optional because of type inference. So type annotation. So when you write int a, int b, float x, float y. So when you specifically tell the type, that is type annotation because of type inference. So type inference, what is type inference? So if you are writing where a equal to 10, where a equal to 10, so compiler automatically knows what is the type of A due to the type inference feature. So type inference is the feature in Dart language. It is also in Swift. So what is type inference? So based on the type of the value on the right hand side, if you are writing var x equal to 10, so on the right hand side you are writing 10, it means it's an integer. So compiler will automatically know that okay, uh, the type of the variable x is an integer. Okay, so you don't need to uh, although types are mandatory, type annotations are optional. So you don't need to specifically tell int a equal to 10. Okay. The analyzer can infer types for fields, methods, local variables, and most generic type arguments. When it does not have enough information to infer a specific type, it uses the dynamic type. So you can also write dynamic a equal to 10, and later it can be a equal to something else because you are creating a dynamic type. Here is an example of how type inference works with generics. Example, a variable named arguments hold a map. So where basically here we are going to talk about map, as map, dictionary, whatever you say it, key value pair. So let's see what is this example. So here we are getting a variable, the name of the variable, sorry. Here we are getting a variable. So this is a type annotation. We are specifically telling the type. The type is a map, is a dictionary with a key value. So the key is going to be of string format. Value is going to be dynamic. Dynamic means it can be integer, it can be float, it can be string. In Swift, we have any keyword. So we also write in Swift language, we say map. Key and the value is going to be any dynamic. I hope you got it. So this is the type annotation. This is the name of your variable. On the right hand side, this is the key value pair. So key is argument A, value is hello, key is argument B, value is 42. Key value pair. Alternatively, natively you can use var or final and let Dart infer the type inference. So here, if you see on the left hand side, we are not annotating the type. This is the type annotation. Here we are not writing it. So how does compiler know that this variable is of what type? It is because of the right hand side value. So on the right hand side, because of the type inference feature, compiler understand okay, it's a dictionary where keys are string, argument A is a string, argument B is a string, and value is a string and value is an integer. So it will automatically become a string dynamic. I should write dynamic like this way. It is commented. I think I wanted to write map string is the key and dynamic type is for dynamic types. Okay. So I believe here it's clear what is type inference, what is type annotation, and I mean two ways of writing or declaring your variables. It should make sense. Runtime checks in the Dart VM deal with the type safety issues. So type safe, Dart is type safe. So you cannot say 10 plus alloc. You cannot do that. Type should be safe. That is what type safety is. So runtime checks in the Dart VM deal with type safety issues that the analyzer can't catch. Below code throws runtime exception. It's an error casting list of dogs to list of cat. So here you can see this is a code. It's a list of animal. The name of the variable is animals. A square bracket, it means we are creating a list, or you can say array. We are getting an array of dog objects. Here we are saying list cat. So the type here we are saying list cat, and we are trying to typecast animal, which is the list of dog, we are trying to typecast it to a list of cat. It is not possible because shift because Dart is type safe. Okay, so you will get the runtime exception. Dart does not have the keywords public, protected, and private. If an identifier starts with an underscore, it is private to its library. Identifiers can start with a letter or underscore followed by any combination of those characters plus digits. This class, the the name of the class is employee. Opening braces, closing braces, int means type. So we are writing or basically here annotating the type. So we are saying int private variable, whatever variable name you want to give, you can give it, and underscore means it's private and the initial value is equal to 0. So there is no type inference because we are using the type annotating. We are annotating the type, so compiler does not need to wait for the type inference. Dart parses all your code before running it. You can provide tips to Dart, for example, by using types or compile time constants to catch errors or help your code run faster. Yes, so basically it's good practice to annotate the type. Basically, it is good practice to write whatever type you are expecting on equal to 0. So make it int. If you are making it a string, so make it a string. It's better practice. The programming languages which are machine independent and are written in English language are known as high level languages. For example, Dart, Python, and Java. These are all high level programming languages. Dart, Kotlin, and Swift are type inferred language. I mean, we have already discussed, I think, the same thing again. Let's go ahead with this also, which means you do not need to be specifically type the of a variable. In the below example, we do not need to tell I is an integer variable. See here. So here you don't need to tell int I equal to 10. No, just where I equal to 10. So compiler will automatically know due to the type inference that the type of I is integer. Okay, so let's run some code. So here there is some code script which is talking about data type which is integer. So let me show you. So here it's all about it's a Dartpad, and to run basic code snippets you can use Dartpad to it's like Python's notebook. You can, I mean, you cannot develop an enterprise application using the Dartpad, but yes, it's good for writing some code or practicing some language. For that point of view, it is good. Okay, so void main, this is the entry point. It's very common in Java, void main. Okay, in Dart also we write main. If you are creating the iOS app, there is also main. So main is the entry point for a program. Okay, so here is the same thing. Here we are declaring a variable. The name of the variable is a, and the type is integer, because in this entire script we are going to talk about basic integers. Okay, integer, float. I have a couple of examples. So this is variable a equal to 2. So the type of a is integer due to the type inference. The type of b is integer because of the type inference feature, because on the right hand side we are putting the integer variable. This is how we can add var c equal to a plus b, and like in JavaScript you can do console.log. In Swift you can do print. In Dart also you can do print. In Objective C you can do nslog. Okay, so this is the way you print something. So print sum of two numbers is, this is the format specifier. This is the format. So because this is a string, you are writing something in a string format, double quotes. You are writing something in the string format, and within the string format you want to access an integer. So you have to use this format. X equal to 5, x equal to 6, where is it x minus y? Very simple. And we are accessing the result using $z. Simply multiply m equal to x into y. Correct. So you can see division where d equal to x divided by y. And these are all the outputs, sum of two numbers. So Dart Patch is very good for initial learning of Dart language. So these are all the outputs. Here is the run button. You can run, click on the run button and it will be out. So we basically it is integer. Example, you use integer for the requirement of your project if it is required. Let's talk about float. If you are not sure about the value, it have to be a number. You have the option of float. Suppose you have to uh, use 1.2, 3.2, some kind of fractional values in your code base. You are working for an e-commerce project and you are working with price. So it can be anything, correct? $10, $10.2, $50, 10 rupees, 10.2 rupees, anything. So you need something, a data type through which you can support the floating numbers. Okay. So for that we have float. So here you can see the similar thing. Again, A, this is float, this is float. Here we are adding these numbers. This is the example of subtraction. So you have float, you have float. We are subtracting. This is the example of multiplication. So here x and y, x into y, and we are performing the multiplication. In the similar way, we have division, t equal to x divided by y, whatever is the value you can see. And here is the example of modulo. So basically, a very basic thing about the data types. So they are almost similar to other languages. But I just discussed the code so that you feel confident, and it's so easy. Thank you. So I will stop here, and in the next videos, we will talk about more data types. Thank you.